So let's look at the sine function. Now that we've talked about cosine, talk about it with somebody. How would you restrict the sine curve? Obviously not 1 to 1, right? How would you restrict the sine curve so that it's 1 to 1, so that its inverse will be a function?
I think we say negative pi over 2, positive pi over negative. If I was a negative pi. Oh, I like it.
A nice little diagram here. Get that mirror image of each other, right? Over the line y equals x, but not a function. So again, we must restrict the blue sine curve so that the red inverse sine is a function. We need to make this blue curve 1 to 1 again. What did you come up with? What did you want to do?
Negative pi over 2 to pi over 2.
Right, and again, there are an infinite number of sections that you could keep to make it 1 to 1, but the one that includes 0, closest to 0, would go from negative pi over 2 to pi over 2. Now, why couldn't we keep the same thing we did last time? Well, because if we went from 0 to pi over 2, we're going to fail the horizontal line test for the blue curve, and therefore the red curve will not be a function. So Darian had it. We're going to restrict it from negative pi over 2 to pi over 2. And that's as much as you can keep. If you go any further, this is going to come back up, fail, and then this will fail, and likewise this will fail. So let's talk about similar results for sine and inverse sine. So this time f of x is sine x, and inverse of f of x is inverse sine of x. Okay? And what is the domain that we came up with for the original function, and what is the range for the original function? How do we restrict the domain of the original Sammy? The inclusive negative pi over 2 to pi over 2, what would that be in degrees? What? Yes, but it's negative. So negative 90 to 90 degrees. Good, inclusive. What's the range? What's the range, Josh?
Negative 1 inclusive.
Yeah, same as it was for cosine. The sine and cosine ratios are always values between negative 1 and 1. Anything higher than 1, no. Anything lower than negative 1, no. And then, of course, we're going to switch it over here. So the domain of the inverse will be the range from the original, and switch it up. The range of the inverse will be the domain from the original. Bless you. Now, I want to point out something now that doesn't seem like a big deal right now, but it will be very soon. In inverse cosine, when you use that on your calculator, you can get an angle between 0 and 180 degrees. That includes acute angles, right angles, and up to and including straight angles, but also obtuse angles. Inverse sine will never give you anything bigger than 90. You'll never get a straight angle, you'll never get an obtuse angle. When we start looking at triangles that are not right triangles, there might be obtuse angles. You would not want to use inverse sine, if you can avoid it, to find that angle, because it's not going to show it to you on the calculator. You'd rather use inverse cosine if possible. So keep that in mind, keep that tucked away in the back of your head, that does have important consequences for us moving forward. Okay? But let's move on. Any questions there? Oh, let me put this picture here. So here we went from 0 to 180, or 0 to pi radians inclusive. Here we go from negative pi over 2 to pi over 2 inclusive, or negative 90 degrees to 90 degrees inclusive. And so here we were quadrants 1 and 2. Here we're quadrants 1 and 4. These restrictions are important to know and memorize. And why do we have them? Well, to make it 1 to 1, but specifically we just agreed on those as a matter of convention. It could have been something else, but this is what convention dictates. Okay? How about tangent? Take a look at your tangent curve, see what you come up with. Pause it there. Thank you.